In this video, we will be talking about contactors. We will explain what a contactor is and how they work. We will also explain how to wire a contactor and the difference between a contactor and a relay.
What is contactor? A contactor is a device that is for making and breaking an electrical power circuit. For example, we usually use a contactor for turning on and off an electrical motor. Now you may ask, why do we need to use a contactor? Can't we connect the motor directly to the PLC? Well, the short answer is no. Why? Because you don't want to connect a high voltage electric motor to your shiny expensive PLC directly. This will damage the PLC cards if there are any electric surges on the motor's side.
So, what we do instead, we use a contactor to connect the PLC to the motor indirectly and safely. What do we mean by indirectly, you ask? Well, all contactors have a low voltage coil. We connect the PLC output to this coil. This coil usually works with a 24-volt DC signal. Once the coil is energized, an electromagnetic field will be created. This electromagnetic field then causes the three contacts here to be closed, and that's how the three-phase power will reach the motor and can turn it on. Looks like magic, right? So, there is no electrical connection between the coil and the contacts. The contacts will open and close via the electromagnetic field created by the coil. In the normal state and when the coil is not energized, the contacts are open, and when a 24-volt DC signal is sent from the PLC, the coil will be energized, the contacts will close and the motor turns on.
With this setup, there is no direct connection between the PLC and the motor. That's how you can turn on and off a big high voltage electric motor indirectly and safely and make sure your PLC card won't be damaged if there are any electrical surges on the motor side. So that's why we use a contactor.
Contactor vs relay. Now that you know why we use a contactor, you may want to know how a contactor is different from a relay. You may say, a relay also works in the same way. Can't we use a relay instead of a contactor to turn on the motor here? The answer to this question is no. A relay works the same way as a contactor. That means a relay also has a coil and some contact. When the coil is energized, the contacts will close. This is the same way a contactor works, right?
But here is the difference. A relay is usually used for smaller devices with lower current and voltage rates. A contactor, however, is used for bigger devices with higher current and voltage rates. So, relays are used to turn on and off small devices and contactors are used for turning on and off bigger devices. Very simple. How to wire a contactor now? Let's talk a bit about the wire terminals on the contactors. 1. Coil terminals on the front of the contactor. You'll see two wire terminals of A1 and A2. This is where we can connect a 24-volt DC power to the coil to energize it. The A1 wire terminal is where the 24-volt DC positive signal wire gets connected, and the A2 wire terminal is where the 24-volt DC negative signal wire gets connected.
Obviously, the reason that we are connecting a 24-volt DC power to these terminals is that the coil works with a 24-volt DC power for this contactor. For some other contactors, this coil may work with different voltages such as 12-volt DC or maybe 220-volt DC. Depending on the type of the contactor, the coil can also work with AC voltage. For example, the contactor's coil may work with a 24, 120, or 220-volt AC power. So before connecting the wires to the coil, you first need to check the coil voltage. Most of the contactors, like the one we have here, work with a 24-volt DC power. Contacts terminals. On the other side of the contactor, we have 6 other wire terminals. The wire terminals on the top are labeled from left to right with L1, L2, and L3. The wire terminals on the bottom are labeled from left to right with T1, T2, and T3. The L1, L2, and L3 terminals are where the power wires connect to the contactor. The T1, T2, and T3 terminals are where the device wires connect to the contactor.
The L1 contact connects to the T1 contact, the L2 contact connects to the T2 contact, and the L3 contact connects to the T3 contact. All of my contactor's contacts are normally open. With the coil energized, the device connected to the T1, T2, and T3 terminals does not have power. When the coil is energized, the device will now have power. Auxiliary or feedback contact terminals. As you can see, we have another set of wire terminals on the front end labeled as NO or normally open. This is a simple normally open contact referred to as an auxiliary contact or a feedback contact.
This contact is used to send a signal to the PLC input about the contactor's health. What do we mean by that? The way that this contact works is that when the coil is energized and these three main contacts are closed, this feedback contact will be closed as well and send a signal to the PLC input. However, when the contactor is broken and energizing the coil will not result in these three main contacts being closed, the feedback contact will not be closed either and no signal will be sent to the PLC input.
This way, there is a way for us to be notified if the contactor is broken. We have discussed this more in our Level 2 PLC programming course, and there is a sample PLC program that shows why we always need to use a feedback contact and how to use that contact in the PLC program to get notified when the contactor is broken.
How to wire a contactor to the PLC and motor. Okay, so, to control a motor using a PLC through a contactor, you need to connect the PLC output to the coil to be able to energize and de-energize it. You connect a three-phase power supply to L1, L2, and L3 from one end, and then from the other end, you connect T1, T2, and T3 to the motor. To be notified when the contactor is broken, you need to connect this auxiliary or feedback contact to the PLC input.
You also need a start and stop switch to be connected to the PLC input. This way, when you press the start switch, the coil will be energized, the contacts will be closed and the motor will be turned on. When this happens, the feedback contact will be closed as well and a signal will be sent to the PLC input, telling us that the contactor is working properly. When you press the stop switch, the coil will be de-energized, the contact will open and the motor will turn off.
In this video you learned that we use a contactor to turn on and off heavy and high voltage electrical devices such as motors, fans, pumps, etc. The reason that we use a contactor is to control these heavy high voltage electrical devices indirectly and safely via a PLC and not to connect the PLC directly to these output devices. The main difference between a contactor and a relay is that a contactor is used for turning on and off heavy high voltage devices, but a relay is usually used to turn on and off smaller low voltage devices. We hope that you now clearly understand what a contactor is and how it works. Please let us know if you have any questions about the contactors or about relays in the comments below and we will get back to you in less than 24 hours. Got a friend, client, or colleague who could use some of this information? Please share this video.